Hi students, today I am going to discuss about the previous year question paper. The chapter name is haloalkanes and haloarenes, simply called alkyl halides and aryl halides. In this lesson, you have to concentrate more on the following. I will tell you that first IUPAC name, then the name reaction, the reasoning type questions. After that, the substitution nucleophilic reaction, that is SN1 and the SN2 reaction. The SN1, SN2 reaction, that is order of the reactivity. You have to must know that order of the reactivity. After that, the product identification, then the compound identification type of question. So then the reasoning type question. These things you have to more concentrate in this lesson. Not only in this lesson, all the organic lesson, particularly the first 4 chapters in the part 2. Haloalkenes and haloarenes, then alcohol, phenols, ether, then aldehyde, ketone, carboxylic acid, after that amines. In this 4th chapter, the similar type of the questions will come. Some more chapter like chemical test, distinguish the chemical test also will come. So these things you have to more concentrate in this chapter. Hello students, see today I am going to take organic chemistry. The lesson name is haloalkanes and haloarenes. This is previous year question paper, solving of the question paper. Now, in this lesson, you have to concentrate these topics. First, the IUPAC names, then the naming reaction. The naming reaction like Sandmeyer reaction, Woods reaction, like that. That is the called a naming reaction. Then the substitution nucleophilic reaction. The substitution nucleophilic reaction, one is bimolecular reaction, another one is unimolecular reaction. That is SN2 and the SN1 reaction. After that, the compound identification types, then the product identification types of reaction. These are very important in this lesson. Then the conversion, then reasoning type question. These type question in all 4 chapters like haloalkanes and haloarenes, then alcohol, phenol, ethers, aldehyde, ketone, carboxylic acid and amines. All these lessons having completely this type of question except this SN1 and the SN2 reaction. Generally, these type of questions will come. Okay. Now we will see this type of reaction. Okay, look at this IUPAC name. The question is write the IUPAC name of the following. The first one is there are 4 questions are given. The first one is what? Look at this. This is an aromatic compound. So the numbering you have to give from this way 1, 2, 3. So 1, 2, 3 means first position and the third position having chloro, then the second position having nitro. So that write the answer is 1, 3 dichloro, because 2 chloro positions are the 2 chloro compounds are present. 1, 3 dichloro 2 nitrobenzene. So this is the IUPAC name of this first one. So 1, 3 dichloro, second position nitro, that's why 2 nitrobenzene. 1, 3 dichloro 2 nitrobenzene. Look at the second one. Second one, there are 5 carbon atoms are there, one substituent, that is chlorine. And here the double bond present in this side. That is why numbering you have to give this way 1, 2, 3, 4, 5. Now the fourth position having chloro. So that write 4 chloro. How many word root is what? Pent. So 4 chloro pent, 1 first position having double bond, that is why 4 chloro pent 1 ene. So this is the IUPAC name of this compound. Then look at this third one. Here bromo and chloro. So that you have to preference give this way numbering, that is 1, 2, 3, 4. So here the first position bromo and the fourth position is chloro. Then the word root is what here? Prop. So here 1 bromo, the name is 1 bromo, then 4 chloro, 1 bromo, 4 chloro, Then bute, second position having double bond 1, 2. So that bute-2-ene. So 1 bromo, 4 chloro, bute-2-ene. Then fourth one. Here you have to give the here the bromine is present, here the double bond is preferred. So double bond gets preference, so that the numbering in such a way that is 1, 2, 3 like this. So that 3 carbon atoms only there. Here this is a substituent. So second position having methyl group and the third position having bromo. So that bromine in the alphabetical order you have to write the bromo is first. Which position? 3. So 3 bromo, 2 methyl, second position having methyl group, 2 methyl pro 1 ene. So this is the name of the IUPAC name of this compound. Sometimes the name will be given. You have to draw the structure like this. So the both method is possible. IUPAC name and the structure name will be given and the structure you have to write. The two possibilities are there. So look at this question. Why is the CH2 double bond CH bond CH2 bond Cl more easily hydrolyzed than the CH3 CH2 CH2 Cl? See, this compound is allyl, so that the CH2 double bond CH2 single bond CH2 and this having a resonance CH2 and CH2 like this. So this having the carbocation, the allyl carbocation is more stabilized by the resonance, that is stabilized by the resonance more than this CH3, CH2, CH2, that is called propyl carbocation. So the answer is, you have to write, it is because of this, the allyl carbocation is stabilized by the resonance more than this because of the inductive effect. Simply you can write it, this is inductive effect. So this is the answer. Just a key points because of the inductive effect. See the third question. Why is cyclohexyl chloride is more reactive than chlorobenzene? Here the cyclohexyl chloride and the chlorobenzene. The chlorobenzene having the double bond character between the carbon and the chlorine atom, that is the conjugation, that is delocalization of the double bond. This which has the higher bond dissociation energy than that CCl bond, that is in cyclohexyl chloride. The carbon is having sp3 hybridized, and whereas the carbon in chlorobenzene sp2 hybridized. Here chlorobenzene having the carbon is sp2 hybridization. In cyclohexyl chloride, carbon having sp3 hybridization. So that the chlorobenzene is there is a double bond character between the carbon and the chlorine atom. So they have a higher bond dissociation energy. That is why cyclohexyl chloride is more reactive than chlorobenzene. Then the second question, why is the chloroform stored in dark color bottle? Usually the chloroform reacts with oxygen, the presence of sunlight. What happens means it produce phosgene gas, that is a poisonous gas, COCl2. That's I'll write here CHCl3. The chloroform react with oxygen, the presence of sunlight. So what happens means COCl2 and HCl. This is called a phosgene, is a poisonous gas. Okay. The next question is why. The next is why dextro and the levo. The dextro and the levo rotation, that is why dextro and LAVO rotatory isomers of butane 2R are difficult to separate by fractional distillation. Here the boiling point, the physical properties differ in the optical rotation and the biological properties. Usually it is because they do not differ appreciably in their boiling point, that is the physical properties, but differ in the optical rotation and the biological properties. The difference of the physical and the biological properties. That is why the dextro and LAVO rotation isomers of the butane 2R are difficult to separate by the fractional distillation. You have to write the key pointers, their boiling point, like physical properties and the biological properties, that is the optical rotation. See, look at this question. Out of the CH3 thrice CBr, that is tertiary butyl bromide and the tertiary butyl iodide, which one is more reactive towards SN1 reaction and why? Then the second question, out of this, the two compounds are given here, which is optically active and why? First question answer, here the CH3 thrice Br, that is tertiary butyl bromide, and this having the tertiary butyl iodide. Here, compared to this and this, iodine is a better leaving group and they have a low bond dissociation enthalpy. That is why this is more reactive towards SN1 reaction. So, because of the low bond dissociation enthalpy and due to bond length also, this is also one of the reason. So, this is the first question answer. Then the reason is low bond dissociation enthalpy and iodine is a better leaving group compared to the bromine because of the size and the bond length also. Then the second question answer is, out of this, the two compounds are given here, which one is optically active and why? See, here this carbon, look at this, here one carbon, that is a CH2, just I am writing the structure, the bond line to just like this, CH3, then CH2, OH. So this structure, and this structure is CH3, CH3, then CH, OH and CH3. See, look at this structure. Here, which is optically active and why? Look at this structure. Here, take this carbon and take this carbon. In this structure, take this carbon. Here, the CH2OH. So, that's mean, just I am writing this structure, CH2. Then the remaining part like this. So, just I will write here the CH2. And this structure I am going to write like this. Now, take this carbon and here also take this carbon. Look at this one group and this one group and this one group and this one group. Look at this one, this is the surrounded, carbon surrounded. This is called asymmetric center. The asymmetric center or stereo center are called chiral carbon. When the compound having chiral carbon means the compound should be optically active. Here, the two hydrogen atoms are present. So that the same atom or same group present means that is not considered as a chiral carbon. But here all this, the carbon surrounded atoms or group of atoms is differ. That is why this considered as a chiral carbon, simply called chiral carbon or stereo center or asymmetric center. That is why this is optically active compound. Out of these two compounds, which is optically active? So this compound is optically active. You have to separate like this, whether the compound having chiral carbon or not. When the compound having chiral carbon means that compound should be optically active. The question is what? Which one is optically active? So this is optically active. So look at this question. Out of the cyclohexyl chloride and this the cyclohexane ring having the CH2Cl, which is a more reactive towards the SN2 reaction, and why? Then the second question also, chlorobenzene, and the chlorobenzene contains one nitro compound which is more reactive towards the SN2 reaction, why? The first question answer. Here you have to check whether which is a primary and the secondary halide. So in this case, the second one is a primary halide. The second one is the primary halide. Then this is not a primary halide. This is a secondary halide. So that compared to this, the primary and the secondary halide. So primary halides are more reactive towards the SN2 reaction. So that the first question answer is CH2Cl. So this carries half mark, and the reason this is because of they contain the primary halide. This carries half mark. So this is the answer. Then second question, out of this one, the benzene ring having one chlorine, and this benzene ring having one chlorine and the nitro compound. Which one is more reactive towards the SN2 reaction? See, this one and this one are same, but here the only one, the NO2 is present. So that NO2 is a electron withdrawing nature. So the NO2 electron withdrawing nature means what happened? This should be a more reactive towards the SN2 reaction, because usually they stabilized by the intermediate, that is electron withdrawing stabilized intermediate negatively charged ions. That is why this is more reactive towards the SN2 reaction. See, this type of question, SN and SN, there is SN2, SN1 type of question is very important. This type of question will come every year. You can see that question paper not only like that, sometimes name will be given. You have to arrange the structure, then whether it is a primary halide, the secondary halide, you have to concentrate, then you have to answer. Simply, I just recall this. SN2 and the SN1 reaction, the order of the reactivity. Usually the alkyne halide simply is more reactive than primary halide, then secondary halide, then tertiary halide. This is the order of the reactivity for the SN2 reaction. And SN1 just vice versa, that is opposite. Tertiary is more reactive than secondary, is more reactive than primary, is more reactive than the methyl halide, simply alkyl halide. Okay, so this is the order of the reactivity. Okay, SN2 gives inverted configuration, and the SN1 gives the retention configuration. So just you have to remember this thing, then you can easily answer this type of question, whether the given halide is primary, secondary, or the tertiary halide. Then after that you have to check whether the reaction towards faster for SN2 or SN1. Okay, then you can easily answer this type of question. So next question, predict the major product formed when sodium ethoxide reacted with tertiary butyl chloride. So here the alkene is formed. The reaction gives the evidence. Here the tertiary butyl chloride reacts with the sodium ethoxide. What happens? This goes to the sodium chloride, and the remaining is what here? The CH3, that is CH3 thrice C forms like this. See, this will be converts to alkene. So a double bond is present, that is why alkene and ethanol is formed. So the reaction you have to write, and the answer carries mark. For simply you can write it, they predict the major product formed when the sodium ethoxide react with tertiary butyls. Means the major product should be alkene. Simply you can write it alkene, and the byproduct here, this is the byproduct, sodium chloride and the ethanol. Then the second question is, why is it necessary to avoid even traces of moisture during use of the Grignard reagent? When the Grignard reagent is used, what happens when react with waters mean they produce alkanes. So that is why you have to avoid this. So why it is necessary to avoid even the traces of moisture during the use of Grignard reagent? Mean it forms alkanes. You have to write the key pointers. It forms alkanes, and the reaction like this, RMgX plus H2O gives RH. So this is the alkane is formed. That is why the reason we have to avoid this. Okay. See, the next question is, how will you obtain bromobenzene from aniline? So you have to write that aniline. From aniline you will get that bromobenzene. The reaction is aniline treatment with sodium nitride and HCl. Sodium nitride and HCl. Then the temperature is very important, 0 to 5 degrees Celsius, or 273 to 278 Kelvin, or 0 to 5 degrees Celsius. Then it converts to benzene diazonium chloride. It converts to what? Benzene diazonium chloride. This is called benzene diazonium chloride. Again, treatment with that copper and bromine, or you can use it Cu2, Br2 and HCl. So what happens to produce? The answer is what? That is bromobenzene. You will get the bromobenzene and N2. Bromobenzene and N2. Simply, this is called Sand-Meyer reaction, and also that HCl. So here, this is called Sand-Meyer reaction. Sometimes name reaction will be directly asked, sometimes indirectly. So this is called Sand-Meyer reaction, one of the name reaction. The name reaction like this also possible to come. So how will you obtain bromobenzene from aniline? Sometimes they will changing of the question means chlorobenzene to aniline. Just using of this bromide, instead you have to use chloride. Okay, iodo means iodide, like this. Okay, so this is a name reaction called Sand-Meyer reaction. Name reaction. See, look at this. Write the following name reaction. The first one is Wurtz-Fittig reaction. Second one is Fittig reaction. First, the Wurtz-Fittig reaction. The Wurtz-Fittig reaction is the different alkyl and aryl halide. That is, mixture of alkyl and the aryl halides react with the sodium in the presence of dry ether to form like the C. This is a different alkyl halide. One is, this is aryl halide and this is the alkyl halide. To give alkane, simply this and the NaX. Just you can separate it like this. So what happens? This gives like this. So the different types of the alkyl and aryl halide, that is our mixture of the alkyl and aryl halide, the presence of sodium and dry ether to form alkane and the sodium halide. So this type of reaction is called Wurtz-Fittig reaction. And the second is a Fittig reaction. Simply just just using the same the aryl halide. For example, 2 moles of the aryl halide react with sodium in the presence of dry ether, same thing, you will get diphenyl. Simply you will get diphenyl and the NaX. So this is the phytic reaction. The first one is Wood's phytic reaction. The second one is phytic reaction. This is the name of the reaction. So next is the product identification type question. Write the major products of the following question. The first one, chloroethane treatment with potassium nitrate. What is the product? Then second one is 2-bromo-butane gives react with potassium hydroxide in the presence of ethanol on heat gives what? The first reaction gives the product as the CH3 CH2, this will goes KCl. What happens? Then it will come ONO like this, or NO2. Simply write ONO like this. Okay, CH3 CH2 NO2. The nitroethane is the product. Then the second question, 2-bromo-butane react with potassium hydroxide in the presence of ethanol on heating. What happens? It gives alkene. So the product is CH3 CH double bond CH CH3. So butene, and this converts to this KBr and H2O. So this is the answer. So CH3 CH2Cl react with KNO2 gives CH3 CH2NO2. Then the product of this nitroethane. Then the second reaction, CH3 CH2 CHBr CH3 react with KOH and alcohol and heating, you will get alkene, that is butene and potassium bromide water. Next is the conversion type question. How do you convert the following? First one is prop 1-ene to 1-fluoropropane. Second question is ethanol to propanitrile. Then the first question answer is here the prop 1-ene react with hydrogen bromide in the presence of peroxide. It converts to bromopropane. Then the bromopropane react with silver fluoride, that is called a Schwarz reaction, to convert fluoropropane, that is called 1-fluoropropane. So this is the conversion, first conversion. Then the second one, ethanol. This is ethanol to propanitrile. The ethanol react with phosphorus trichloride to form ethyl chloride. This ethyl chloride react with potassium cyanide. What happens? You will get the propanitrile. So this is the conversion type. Usually conversion type also conversion type questions also come. Okay. This is in this unit just I gave a 2 conversion reaction. So this type of question, compound identification type question. The question is primary alkyl halide, that is C4H9Br is reacted with alcoholic potassium hydroxide to give compound B. Then the compound B is reacted with HBr to give compound C, which is an isomer of A. So when A is reacted with sodium metal gives compound D. So C8H18, which is a different from the compound formed when N-butyl bromide is reacted with sodium. Write the structure of A and write the equation for all the reaction. So this is the question. Here the answer is there are the two primary alkyl halide having the formula is C4H9Br. Okay, they are N-butyl bromide and isobutyl bromide. So these two types. So N-butyl bromide and the isobutyl bromide. This is the N-butyl bromide and this is the isobutyl bromide. So here therefore the compound A is N-butyl bromide or isobutyl bromide. Now reacts with the sodium metal the presence of dry ether to form the molecular formula like this C8H18, that is called N-octane. This reactive, this means gives 2,5-dimethyl hexane, that is compound D. Okay. See, the next reaction is the compound D, that is 2,5-dimethyl hexane reactive gives, that is compound A reacts with the alcoholic potassium hydroxide to gives compound B. Hence, the compound B is what? 2-methyl propane. I will write the reaction. See, look at this reaction. That is also that compound B reacts with that hydrogen bromide here. The hydrogen bromide to give compound C. This compound B react with hydrogen bromide, that is called Marconic of addition, to give compound C, which is isomers of A. This is isomers of A, and hence the compound C is what? 2-bromo-2-methyl propane. So this is the answer. The first one, the given, already given, that is, it is given the compound A reacts with alcoholic. This is alcohol is potassium hydroxide to give compound B. Okay. Hence the compound is what? 2-methyl propane. So this is 2-methyl propene. Hi students, today we were seeing the haloalkenes and the haloarenes chapter, name reaction, IUPAC names also we were seeing in this video. Then type of reaction, the chemical reaction, like reasoning type questions. Then the compound identification, product identification questions also we were seeing in this video. Just go through and prepare well your examination. Thank you.